Greetings and salutations, everybody. This is Jacob. Okay, so how the heck do we solve this problem? Seems bewildering. Well, it's a little simpler than it looks, my friends. Okay, let's look at the initial conditions, as I always urge you to do whenever you don't know how to do something. What does it say? It says that different outdoor activities can't take place on consecutive days, and that on any given day, Kevin either goes spelunking, kayaking, or takes a day off, a rest day. So let's try to turn this information into an algorithm. Okay, let's start from day one. How many possibilities are there for 1 day of vacation? Let's say Kevin takes 1 day of vacation instead of 9. How many possibilities are there? 3 possibilities, right? A no-brainer there. So day 1 possibilities equals 3 possibilities. How about 2 days of vacation? Now here is where it starts to get tricky. Day 1 possibilities and day 2 possibilities aren't independent events. Day 2 possibilities depend on what takes place on day 1. So we can't just multiply the possibilities. So what do we do then? We add. So day 2 possibilities equals the possibilities that day 1 is a rest day plus the possibilities that day 1 is not a rest day. So what are the possibilities that day 1 is a rest day? It's 1 times 3. So since day 1 is a rest day, then the second day you'll have 3 open possibilities. Either Kevin goes spelunking, or he takes another rest day, or he can go kayaking. So it's 1 times 3 equals 3 possibilities. Plus the possibilities that day 1 is not a rest day. So what are the possibilities that day 1 is not a rest day? So the possibilities are either day 1 is a kayaking day. So if day 1 is a kayaking day, then there are 2 possibilities on day 2, either another kayaking day or a rest day. And likewise, if it's a spelunking day, then there are 2 possibilities on day 2, either another spelunking day or a rest day. So it's 2 times 2. Here we multiply, since they're independent events. So altogether, it's 1 times 3 plus 2 times 2, which is 3 plus 4, which is 7 possibilities on the second day. Okay, so now we found the 2-day vacation possibilities. What do we do now? In order to find the 3-day vacation possibilities, we just follow the same formula. We calculate the possibilities that the second day is a rest day and the possibilities that the second day is not a rest day. So we have possibilities that the second day is a rest day, which is the possibilities that day 1 is a rest day times 1, plus the possibilities that day 1 is not a rest day times 1. So it's 1 times 1 plus 2 times 1, which is 3. 3 possibilities. And the possibilities that the second day is not a rest day, we just subtract the possibilities that the second day is a rest day from the total amount of possibilities for the second day. So it's 7 minus 3 equals 4 possibilities. So now we're ready to calculate the total amount of possibilities on the third day. So day 3 possibilities equals possibilities that the second day is a rest day times 3 plus possibilities that the second day is not a rest day times 2, which is 3 times 3 plus 4 times 2, which is 9 plus 8 equals 17 possibilities. And we keep going in this manner. So we found our desired algorithm until we get to day 9 possibilities, which is what the problem is asking. In all the possible ways Kevin can schedule a 9-day vacation, given these initial restrictions, are 3,363 possible schedules. And that's your answer. 3,363. Can't say if that's an intuitive answer or not. Well, actually, scratch that. I anticipated less possible schedules than that. But I love it when I get counterintuitive answers once in a while. It means that I've encountered a problem that can prove my intuition. So yeah, that was a fun problem, wasn't it? Let me know in the comments section if you found it difficult, or if you did it another way. As always, smash those buttons like they owe you money. And if you have a puzzle suggestion, then send it my way. I'm more than happy to showcase a puzzle that you're fond of, or that you have trouble with. Lots of goodies in the pipeline, guys. So stay tuned. Don't go anywhere. That's pretty much it for now. I'll see you guys in the next video. Bye-bye.